Hello my dear students, welcome to the class of 12th English medium. The subject is statistics, part 2, chapter 2, random variable and discrete probability distribution, brought to you by Vitan sir. Previously we have studied about the discrete probability distribution and also completed exercise 2.1. Now, let me ask you guys a question that what if we talk about the events in life where there are only two possible options which we have. For example, if we toss a coin, there are only two possible options, that is tails and heads. If we apply for a job, again there are only two possible options, rejected and accepted. If we let loose an arrow from our bow, there are again only two options. It does not hit the target and it hits the target. That means in all of these outcomes, there were only two possible options. No third option was there. So there are many events in life where you only have two possible outcomes. These outcomes, we can say that whether you succeed in what you are doing or you fail in what you are doing. For example, while tossing a coin, I want heads. So if I get heads, I succeed. If I don't, I fail. For if applying for a job, if I get accepted, I succeed. If I get rejected, I fail. While letting loose an arrow towards the target, if it hits the target, you succeed. If it does not hit the target, you fail. That means the random experiments which only has two possible outcomes, which are also mutually exclusive, because you can't succeed and fail at a single point of time. You either succeed or you fail, so they are mutually exclusive and there are only two possible outcomes. We call these random experiments as dichotomous experiments. I will repeat once again, dichotomous experiments. So the random experiments which only has two possible outcomes, which are also mutually exclusive, we call them dichotomous experiments. And if we denote the event of success as capital S and event of failure as capital F, then the probabilities of these events, because these are random experiments, so the probabilities of these events can be denoted as for success P and for failure F. So the probability of success will be P and the probability of failure will be Q. So probability of S is P and probability of F is Q. It also means, because these are probabilities, P is more than 0 but less than 1, Q is also more than 0 but less than 1. As there are only two possible outcomes and both the events are mutually exclusive, okay, P and Q are there, and our rule from very before has been total of all the probabilities must be 1. So P and Q, when we add them, must be 1 and they are mutually exclusive. So we can say that P plus Q is 1. So when we change the side of Q, it becomes P is equal to 1 minus Q. If we change the side of P, Q is 1 minus P. So remember these things which I have written here. P plus Q is 1, P is equal to 1 minus Q, and Q is equal to 1 minus P, because this is something which will be used a lot of times in this chapter. Now, Bernoulli trials. These are a specific kind of trials, and let's see what is its definition, and you will understand why we have to study these trials. Suppose dichotomous random experiment has only two possible outcomes, success S and failure F. If this experiment is repeated for n times, okay, for under identical conditions, and the probability of success P, where it is between 0 and 1 at each trial, is constant, then such trials are called Bernoulli trials. Okay, it means that we are talking about a dichotomous random experiment, and when this random experiment has been repeated for n number of times, okay, so we are repeating these experiments, we are not doing it just once, we are repeating this experiment for the n number of times. For example, if we are tossing a coin, now usually we know that when we toss a coin once we get two outcomes, when we toss a coin twice we get four outcomes, when we toss a coin four times we get 16 outcomes. But we also know that tossing a coin that many times increases the number of outcomes according to the power, and then calculating probability out of it is difficult. So what if we get a question where we are tossing a coin 10 times? At that time, naturally we are not going to get all the possible outcomes, because it would be 1024, and then out of 10 times, if we are asked that what is the probability of getting two tails out of the 10 times tossing a coin, then naturally we will not be able to calculate it. But using this Bernoulli trials, we can calculate the probability. We will see that afterwards, but here I'm giving you the chance that okay, tossing a coin 10 times is also possible to calculate its probability using the Bernoulli trials, because it's a dichotomous experiment, because a coin only has two possible outcomes, heads and tails, so it becomes a dichotomous experiment, and that dichotomous experiment has been repeated for n number of times under the identical condition, and the probability of heads never change, because there are only two possible outcomes. Each time we toss a coin, heads has a chance of appearing 50% of the time. Simple. So two possible outcomes, success and failure, repeated for n number of times under identical conditions, and probability of success remains constant, then these trials are called Bernoulli trials. These trials were explained first time by James Jacob Bernoulli, hence they are named after him as Bernoulli trials. Properties of Bernoulli trials. Now, this is one of the important theoretical questions. Many times it has been asked for 2 marks. The probability of getting success at each trial remains constant. That means the probability of success of each trial is constant. All trials are independent. That means probability of getting success or failure does not depend on the probability of success and failure of any previous or the next trial. Okay, that means it two trials does not depend on each other. Success and failure are mutually exclusive and exhaustive events. Okay, so 3 points. Number 1, the success remains constant. Number 2, all the trials are internally independent. So if I toss a coin first time, and if I toss a coin second time, the tossing of first time and second time does not depend on each other. So it doesn't matter what I got in the previous trial, it is independent from my current trial. And the success and failure are mutually exclusive and exhaustive. That means P plus Q is 1. They are exhaustive, that means total is 1, and mutually exclusive, that means nothing is there between them. There is no intersection of events here. Now, coming to the main part of this whole chapter, actually, rather than just the topic, because this is the central uh, part of this chapter, that is binomial probability distribution. Now, we have studied that the random variable has been distributed as discrete variable, discrete random variable, and continuous random variable. And the discrete random variable creates a discrete probability distribution, which we just studied in some previous tutorials. So binomial probability distribution is one of the parts of that discrete probability distribution. So if in a discrete probability distribution, rather than having the whole sample space, if we have only two possible outcomes, then we can use the concept of binomial probability distribution to calculate probability using ready-made formulas. So rather than doing combination and permutation and deciding on each individual logic, we can just use a ready-made set of formulas to solve the probability using the binomial concept. So let's see what is a binomial probability distribution, which depends on the Bernoulli trials and the dichotomous experiments. Suppose X denotes the number of successes in a sequence of success and failure obtained in n binomial trials. Then X is called binomial random variable and it assumes any value between the finite sample space 0, 1, 2 up to n. The probability distribution of X can be defined as follows. P, which is capital X, is equal to small x, that is Px is NCx P raised to x Q raised to n minus x. Here NCx, n are the total number of trials, x are the favorable number of trials, P is the probability of success raised to favorable number of trials, Q is the probability of failure raised to total trials minus favorable trials. Here x is from 0 to n, p is between 0 to 1 and q is 1 minus p. It is called, this distribution, this formula is called the binomial probability distribution. If total number of trials n and probability of success p are known in advance, we can calculate probability for each possible value of x. Therefore, n and p are called the parameters of the binomial probability distribution, and we can denote it as b into bracket and p. These parameters are actually the values which are most essential for calculating any particular distribution. So if we don't have the value of n or if we don't have the value of p, then it is not possible for us to calculate the probability for any value of x. But if we have the values of n and p, then we can calculate the value of probability for any value of x, and therefore this distribution is denoted. If I am trying to show which distribution I am using, I will denote it as b NP. Also, remember that if we repeat a Bernoulli experiment capital N times and Px is the probability of getting X success in the experiment, then the expected frequency of each success will be capital N multiplied by probability of X. So that means if my experiment is of tossing 5 coins, and if I repeat that experiment of tossing 5 coins 500 times. So first I will find my probability out of 5 coins, and then I will multiply that probability with the capital N of 500 to get that how many times I get my desired result. I will explain this thing further in a great detail in the later examples and the exercises. The last topic of today's video, properties of binomial distribution. Now, binomial distribution, as I have explained beforehand, is a discrete probability distribution. So it is based on the discrete random variable. Its parameters are n and p. The mean of the distribution is np, which denotes average or the expected number of successes in n Bernoulli trials. So np is the mean. The variance of the distribution is n into p into q, and because standard deviation is square root, it is under root npq. For this, mean is always greater than variance, and variance upon mean gives you the direct answer of q, that is failure. If p is less than 1 upon 2, the skewness is positive. If p is equal to 1 upon 2, then the distribution is symmetric. That means the value of the skewness for this distribution is 0. And if p is greater than 1 upon 2, then the skewness of the distribution is negative. These are the properties, or you can also call them the characteristics of the binomial distribution. This question is many times asked for 2 or 3 marks. You have to write the double number of characteristic than the given marks. That means for 2 marks 4 characteristic, for 3 marks 6 characteristics. So remember these things. How you remember it? This is a discrete probability distribution. Parameters are NP, mean is NP, variance is NPQ, standard deviation is under root NPQ. Mean is greater than variance, variance upon mean is failure, p less than half is positive skewness, p more than half is negative skewness, and p is equal to half is zero skewness. So actually it is quite easy, you just need to remember them like this. In my next tutorial I will start with illustrations because the number of sums in the exercise are very few. So usually I don't teach illustrations, but I will teach illustrations for this concept because I need my students to understand the concept better. So if you have any suggestions, put them in the comment section below. Like my video, subscribe my channel, and share it with your friends. And keep on watching Anekant Academy channel, and I will see you in the next video. Welcome students to Vitan Sir's Anekant Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you and I will see you in the next video.